Okay, we're going to solve systems, continued. So now we're going to talk about what do you do when you have three equations and three variables. Okay, so first off, your goal, and when you're solving this system that has three equations, so we did two, we had x, y point, so we have three, we have x, y, and z. So your answer is an ordered triple. So what's happening now is we have three lines. Okay, now it's hard to see because you're used to like two-dimensional. This is actually three-dimensional. So you'd have three dimensions. There's the three lines that come out of those, and where they intersect is a point. This point is going to be your answer to this. So it should work for all three equations. So your first goal when you're solving this is you want to break it down to what you know how to solve, which is you know how to solve two equations with two variables. So that's your first step. So when I look at the original, I like to see, do I have any of those equations that just have two variables? So I have this one. Okay, I like to number them so I know what I'm going to. Okay, so what I need is since this has x and z, I need to find another equation that has x and z. Well, I don't have anything given to me, so what I'm going to have to do now is I'm going to have to figure out a way to combine these two by using elimination. And if I just want x and z, that means I need to cancel the y's. Okay, so if I have these two equations, and I want to cancel the y's, I don't have to multiply them by anything because I already have a positive y and I have a negative y. So when I combine these two, the y's automatically cancel. And I would have 3x plus 2z equals 9. So I have an equation right here that has x and z, and I have an equation right here that has x and z. So now I have two equations with the same two variables. Okay, so that's kind of your first step. Second step, you take those two equations, and we're going to put them on top of each other. Okay, and now it's like what we talked about yesterday. So I want to see, okay, what can I cancel? So now I have two equations with two variables. So I want to cancel out the x's. So that means I'm going to multiply the first equation by -1. And it doesn't matter if you choose to cancel x's or z's. I'm just going with what I want to do. Okay, as long as you get one positive and one negative of the same number, these variables will cancel. So when I multiply the first equation by -1, I have negative 3x plus z equals 0. This one stays the same. So when I eliminate the x's, I have 3z equals 9, divide by 3, z equals 3. Okay, I've solved now one of the variables. So now I still have to find the x and the y. Finding the first one is the hardest though. It takes the most work. After you find the first one, take this answer, you're going to plug it into one of the two that have two variables. So I could use 3x minus z equals 0 or 3x plus 2z equals 9. I'm just going to go with this one since it's simpler. So I would have 3x minus 3 equals 0. Solve for x, I would add 3. So I have 3x equals 3. Divide by 3. So I have x equals 1. So now I have two of the three that I need to make my ordered, let's call it ordered triple. Okay, after you have two of the answers, you're going to take both of these answers and you're going to plug them into one of the equations that has all three. So I have two of the equations. We have the first one and the second one that both have all three. So I'm going to go with the first one just because it's easier. So I would have 1 plus y plus 3 equals 6. So this would be y plus 4 equals 6. Subtract 4. So I get y equals 2. Whoops, I don't know why I boxed that in. So that's my third one. So then I take all 3 of these and I want to write it like an order triple, and it does still go in alphabetical order. So my answer would be 1, 2, 3. Okay, you want parentheses because it is a point. So you don't use solution sets on these, so parentheses. So that would be your answer. Okay, so this one I start with 3 equations. So what I need to do is I need to get it down now to 2 equations with 2 variables. So let's just say I want to cancel the y's. So pick whatever variable you want to cancel and cancel. So that means I need to combine 2 equations to cancel the y's. Well, the very first one I see that's easy is the first and the last one. Okay, why do I think those are easy? Because one's already a positive, one's already a negative. So if I put these together, and I go to cancel the y's, well, I also notice that the z's cancel, so I get 5x equals 12. So this I can go ahead and solve. It goes ahead and gives me that x is 12/5. So technically I already have one part solved. Okay, now we still need to break it down to 2 equations with 2 variables, so I'm still going to need to try to combine something else that will cancel out my y's. So let's go with the first 2. Doesn't really matter. Well, if I want my y's to get to cancel on the first 2, that means I'm going to have to multiply this first equation by 2. So that would give me 4x plus 2y minus 2z equals 14. My second one would stay the same. Okay, now I notice on this one, my y's and my z's also cancel again. So we're going to solve, so I get 5x equals 5. But this time it says x equals 1. Well, x can't equal 12/5 and 1 at the same time. So if you get a case like this, this would be a no solution. Okay, you can't have 2 things, 2 variables that are exactly the same can't equal different numbers. All right, we're going to do one more. Okay, so first thing you want to do is you want to figure out what variable you want to cancel. Because I don't have one equation that just has two. They all three have all three variables. So just by looking at this, I'm going to cancel the y's just because I already have an equation that just has a y, so it saves me a little bit of time. So I'm going to cancel the y's. And the first thing I'm going to do is I'm going to combine the first and the last to get my first equation. Okay, well since this is a -5, that means I need this one to be a +5. And I'm just going to write them out here so that you can watch the whole steps so it doesn't get confusing. So what we're going to do is if I want this to be a +5, I'm going to have to multiply this equation by -5. So my first one is going to stay the same. But then this equation will become -35x plus 5y minus 15z equals 0. The y's cancel. So I have -32x minus 10z equals 1. So this is our first equation that just has two variables. Okay, then I need to find another way that I can cancel the y's. So I could either do the first two together, or I could do the second and the third one together. I'm going to do the second and the third one together, just for the same reasons. This is already a y, so less I have to multiply by it. So 5x minus 2y plus 3z equals 0. This was 7x minus y plus 3z equals 0. So if I want the y's to cancel, that means I'm going to have to make this one a +2. So I'm going to have to multiply it by -2. So it would be 5x minus 2y plus 3z equals 0. And then I would have -14x plus 2y minus 6z equals 0. So my y's would cancel. So I would have -9x minus 3z equals 0. Okay, important thing when you're breaking these down. These two equations have to have the exact same two variables. If they don't, then you wasted your time because there's no way you can eliminate from there. Okay, so then I take these two equations and I want to do elimination from there. So to me the easiest would be get rid of the z's. So I'm going to multiply the top equation, let's make it +30. So I'm going to multiply by -3. And the bottom equation I'm going to make it negative, so it's already negative, so I'm going to multiply by 10. So I'm going to carry it up here. So I would have 96x plus 30z equals -3. And I would have -90x minus 30z equals 0. So my z's cancel. So I'd have 6x equals -3. Divide by 6, x equals -1/2. Okay, finding the first one's the most difficult. So to find the next one, you're going to take this answer and plug it into one of the two equations that you found with two variables. So I'm just going to go with the first one. So I would have -32 times -1/2 minus 10z equals 1. So this would be 16 minus 10z equals 1. Subtract 16. So negative 10z equals negative 15. Divide by negative 10. Z equals positive 3 over 2. Or you could put 1.5 if you would like. Okay, then to find the last one, you're going to take both of these answers and you plug it into one of the three originals. Okay, I'm going to go with this last one because I think it'll be the easiest to solve for y. It doesn't matter which one you choose. So I would have 7 times negative 1/2 minus y plus 3 times 3/2 equals 0. So this would be negative 7/2 minus y plus 9/2 equals 0. So this would be negative y. And then negative 7/2 plus 9/2 is 2/2, which is 1. Subtract 1, so I have negative y equals negative 1. Divide by negative 1. So y equals 1. Okay, then I'm going to take my 3 points. Now make sure you put them in order. So x comes first, then y, then z. Okay, parentheses because it's a coordinate point. Okay, on Monday we will talk about what do you do when you have 4 equations and 4 variables, and then we'll also do a story problem. So this will get you through probably half of page 528, maybe a little bit more than half.